Hi, let us review an inverting amplifier. In an inverting amplifier, we have the input applied to the inverting terminal and the non-inverting terminal is grounded. And we know that there is zero current at the inverting input. So the current at the inverting input is zero, and there is a concept of virtual ground. Because of that concept, suppose this point is A, then VA will be equal to 0, and this is said to be virtual ground. Now the current through this input resistance Ri, that is the current II will be equal to the voltage across Ri, that is VRI by Ri, and this will be equal to voltage across Ri will be equal to V in, input voltage, minus VA by Ri, and VA is 0, so this is V in by Ri. This is already we have discussed. And current through the feedback resistance Rf, the current here, that is IF, not IF, Rf. IF is the current through feedback resistance Rf, that will be equal to voltage across Rf by the resistance Rf, and this will be equal to what is VA minus V out V0. So V0 represent V out or V out. VA minus V out by Rf, and we know that V out is 0, this term is 0. So this is minus V out by Rf. And since there is zero current here, the input current is 0. So here zero current, that means I will be equal to IF, or this implies V in by Ri is equal to minus V0 by Rf. So the gain of the closed loop gain ACL is equal to V output by V input, that will be equal to minus Rf by Ri. Okay, this we have to note. So the important equations are IF is equal to minus V out by Rf, or we have the output voltage V0 is equal to minus IF Rf. Okay, and the gain of the op-amp ACL is equal to minus Rf by Ri. Okay, now let us discuss about summing amplifier. Basically, a summing amplifier is an inverting amplifier. That's why we firstly discussed about an inverting amplifier. Now, in an inverting amplifier, you have a single input Vi, but here you have three inputs V1, V2, and V3. Now, how to convert an inverting amplifier to summing amplifier? Here we need three inputs, or as many inputs. Suppose I am summing three inputs, then we need three input. If you have four input, you will add another input here. If you have to sum for five inputs, five input voltages, you will have five resistances here, and five in voltage sources will be here, or five voltages will be here. Okay. Now, if I consider this circuit, then the current here, if I consider that current as I, the current I will be a sum of I1 plus I2 plus I3. Okay. Now, what is I1? I1 will be equal to V is equal to IR. So I will be equal to V by R. So I1 will be equal to V1 by R1. I2 will be equal to V2 by R2. I3 will be equal to V3 by R3. Okay, this is plus. This is also plus. So this is total current I. Now here I, that is the current through this resistance Ri, I is equal to IF. I is equal to IF. Similarly, this current I will be equal to the current through the feedback resistance IF. So that means this current the current I1 plus I2 plus I3 will be equal to I F. We have the output voltage V out is equal to minus IF into RF, and IF is equal to I. IF is equal to I, and I is equal to this thing. So now I can write down V0 as, so my V output is equal to minus IF, so that is minus sign, then V1 by R1 plus V2 by R2 plus V3 by R3 into RF. So this is the output voltage. Okay. Now suppose R1 is equal to R2 is equal to R3 is equal to R. Then this equation can be written as V out is equal to minus Rf by R into V1 plus V2 plus V3. Okay. Now what this equation represent? This equation says that the output voltage V out is proportional to the sum of V1, V2 and V3, and this is the condition of a summing amplifier. Output voltage of a summing amplifier is proportional to the negative of the algebraic sum of the input voltage. So that is the condition for a summing amplifier. Now let us take Rf is equal to R. If Rf is equal to R, then our output voltage V out will be equal to minus V1 plus V2 plus V3. So then output voltage is the negative of the sum of the algebraic sum of three input voltages. And then the gain is unity, and the output voltage is the algebraic sum of the input voltages. Okay, so that's about summing amplifier. So let us discuss about non-inverting amplifier. In a non-inverting amplifier, the input signal is applied to the non-inverting terminal. So here we have to apply the voltage signal. And in the inverting terminal, you have an input resistance Ri, and this end is grounded, and from the output to the input, you have a feedback resistance. Let us name it as RF, and this is negative feedback. Some fraction of the output is fed back to the input. Okay, now we know that the input impedance of an operational amplifier is very high. So all of the current that pass through RF, this resistance RF, will pass through also Ri. Since the current to the input current, that is the current into the op amp inverting terminal will be 0. So IRF will be equal to the current through the feedback resistance RF will be equal to the current through the input resistance Ri. Okay. Now what is the voltage across RF? So let us name it as VRF. VRF is the voltage across RF, and that will be equal to, now since these two terminals, this terminal A and B, are at same potential because of the virtual ground. Suppose this is the input voltage Vi, then VR of the input, the potential at VA will be equal to Vi, or input voltage Vin. Okay. The voltage across Ri, VRI will be equal to, that is the voltage here. Voltage across Ri, VRI will be equal to VA minus 0. Now what is VA? VA is V in. So this is V in minus V0 minus 0. So VRI is equal to V in. Now the voltage across RF, VRF will be equal to V out minus V in. V0 minus V in. So this is V RF, and the current through RF is equal to current through RI. That is, now what is IRF? IRF will be equal to VRF by RF, and IRI will be equal to VRI by RI. Okay. Now what is VRF? VRF is equal to V0 minus V in by RF, and VRI is equal to V in. So here you have this equation. Okay. Now that means V0 into Ri minus V in into Ri is equal to V in into Rf. Okay. So that means V0 Ri is equal to V in into Ri plus Rf. So V output by V input is equal to Ri plus Rf by Ri, and that is equal to 1 plus Rf by Ri, and this is the closed loop gain of a non-inverting amplifier. So ACL is equal to 1 plus Rf by Ri, and we have, for a inverting amplifier, in the case of an inverting amplifier, the closed loop gain ACL was minus Rf by Ri. So there we have a negative sign, but here there is no negative sign because the amplifier is now non-inverting amplifier. Okay. Now if the closed loop gain of an inverting amplifier is 100, we have closed loop gain as 100. For the non-inverting type, the closed loop gain here is 1 plus Rf by Ri. So this will be 1 plus 100. So our gain will be 101.